All right, so it's me, Reagan, and this is for Thursday, January 27th for Statistics 313. And point of today's topic is one, to show you a little bit about how Excel works, because it's a very powerful statistics type program, although it doesn't appear to be. There's a lot hiding there, so that's fun. And two, to explain the concepts of central tendency, variability, and z-scores. And the good news is you already know a little something about a few of these topics, so that'll help. All right, so let's start with Excel. Here's an Excel file you're seeing right now. And I made a very small data set, and these are the names of the people in the data set, and these are their scores. So Kyle has an 18, and Ron has a 19, and Sean has an 18. You get the idea. All right, so scores on X for each person. We didn't have to put the names, but I like making up funny names when I can. Also, I know that 5 people or 5 entities in a data set is really small, but just go with me here. We don't really need to demonstrate these principles on a data set with 38,000 cases in it. 5 will show us the same thing and allow us to see it a little more clearly. Okay, so first off, let's say we want to compute central tendency. Central tendency means mean, median, and mode. It's another way of saying average. And again, you need to be specific because you learned probably a long time ago, there are 3 types of averages: mean, median, and mode. We're going to just deal with the mean. To compute a mean is something you've been doing your whole life. You add up the scores and divide by the number of scores. It couldn't be simpler. And if we wanted, we could have Excel do that work for us. But let's do it ourselves. Let's add them up. And so I'm going to make an entry here called sum. All right. And then let's count the number of scores, which I will call n. And then let's compute the mean. All right, which is the sum divided by the number. All right, so first of all, the sum, there are a few ways to do this. I'm just going to type out the equation way. Now, here's something interesting with Excel. If you haven't used Excel before, this is where it gets actually pretty cool. I click on a cell, like this one, and this is cell B2. See that? It's called B2, and it tells you right here what you clicked on. It tells me up in this bar that it's a 22 because that's the value in the cell. And if I click on B6, it's a 19. All right, so if I put my selection here and I hit equals, that's telling Excel this is not going to be just a number or a letter or name or whatever. This is going to be something we're computing. And so I'm saying, all right, I just want you to compute the sum, and I'll use an Excel function for that. So sum is the function, and it's going to say sum of what? And I'm just going to select the cells. So it's saying the sum of B2 to B6, and I could just hit enter here, and that's 106. So you can pull out a calculator and add this up by hand if you like, and you'll see they add up to 106. All right, how many of them are there? That's this line right here. That's n, and we already know they're 5, and we could just enter 5 here if we want. Or if you wanted to do it the Excel way, oh yeah, let me go back. See here, it still says sum B2 to B6, all right? Excel has a function for this. You don't really need to know it. It's called, well, you gotta start that equal sign, count, and it's just gonna tell you how many things there are in the selection. So how many things are there from B2 to B6? And it says 5, just like we thought. And then finally, let's compute the mean, and the mean equals the sum. And watch this, I said an equal sign, the sum. I don't have to type in B8, I can just click it, divided by the count, which is B9. I don't know, okay, something went awry here. All right, let's try that again. The sum, the mean equals the sum divided by the number of things. Okay, well, I don't know what's being stubborn, so I'll just type B9. And there we have it. We got a mean, all right? See, it's sum divided by n. Sum 106, n5, the mean's 21.2. Okay, there, we just did central tendency, average, mean. Just like it's, 4th grade, only we did it with Excel. Now, here's the cooler part. What I love about Excel is that it live updates things. So if I change a value, if I say, hey, Ron didn't have a 19, his score is actually a 9. Now, if you lower somebody's score by 10 points, it's going to lower the sum and lower the mean, right? Watch this. He has a 9, and I hit enter. Sum instantly updates, and the mean instantly updates. Hold on, I'm going to blow this up a little bigger just in case you can't see that. All right? So Ron was a 19 in the real data set. It was as real as a fake data set gets. If I change his score to 9 and hit enter, the sum and the mean are auto live updated. That's one of the cooler things about Excel. As soon as you change a value, here, Ron's a 99 now. That's a really high score. You know it's going to pull up the mean. As soon as you change a value and hit enter, it updates all the statistics that are computed from it. Okay? So let's set that back to what it was. Ron was a 19. All right? So hopefully we're clear on computing means. You can do it with a calculator, by hand, or paper and pencil, whatever. I don't care. That's up to you. I'm just showing you how to do it on Excel because we're going to want to use this mean value here. All right? So what's up next? What's up next is variance. So let's talk about variability. Variability refers to differences in scores. And if you look at the correlation regression book, I'm going to pull that up here. Here's the correlation regression book. And we're in chapter 2 right now. See, chapter 2. All right. And we just did central tendency. See, this is where I stole the data set from, my own book. And now let's get to variability. And variability is about differences in scores. So it's not what's the average score, the mean, but it's how far apart are these scores from each other. Okay, here's a couple of distributions showing you stuff like that. Okay, skipping ahead here. Here is the equation for population variance. So this is variance for a population of data. And you might say, I can't see that, so I'll blow it up a little bigger. There it is. Population variance, all right? Now it looks terrible, but it's not. It's actually really, really simple, okay? But remember, this is population, and population means you're gonna see Greek letters, and there's a Greek letter right there, mu, that's the symbol for population mean, and there's another one, sigma squared, sub x, but the sigma part's important, squared, that's the symbol for population variance, okay? This is a Greek letter just saying sum things up, all right? Add them up, whatever this is, divide by n, all right? So equation for variance, looks bad, it's not. It's actually really, it's almost a mean. It's like a mean plus stuff. Now to compute a mean, what'd you do? You added stuff up, divided by n. In fact, I think I have the mean equation around here somewhere. Let's see, where did I put that? Yeah, there it is. There's the equation for a mean. Add up the stuff, divide by n, you get yourself a mean. I did sample mean. Sample is x bar. Population mean would be mu, all right? But see what a mean is? Sum of x divided by n. And what are we doing for this variance equation? Well, it's the sum of this thing divided by n. Okay, but what is this thing? And let's play around variance and stuff. So I'm going to program this in. All right, let's break this down. It's really just like 3 simple steps. Step 1 is this part of the equation. What's happening here? All right, well, as we said, that's population mean. And of course, that's score on x. So it's score on x minus the population mean. All right, that is called a mean deviation score. Anytime you convert a score on x to x minus the mean, how far apart is it from the mean? It's a mean deviation score because it's a great name. It's how far does the score deviate from the mean. So if the score is right at the mean, it's 0 points away. If it's greater than the mean, it'll be a positive number. If it's less than the mean, you guessed it, negative number. All right, so our first job is to compute mean deviation scores. Okay, we're going to compute variance. We need to get mean deviation scores. So I'm going to label that here, x minus the mean. These are going to be mean deviation scores. Now we know what L. Sebastian's score on x is, it's a 22, and we know what the mean is, it's a 21.2. So L. Sebastian, just a little bit better than the mean. It's just 22 minus 21.2, and I could type that in. I could type in 21 minus 21, or 22 minus 21.2. I could type that in and hit enter, and there you have it, okay? Or we could program things in the Excel way and say, give me that score, what's in B2, minus the mean, which is right here. And we got to do something else because we want to lock this value around the mean around. We don't want that box to move. So you can insert some dollar signs there, what they're called strings. and that locks that box down. That's another Excel move that's worth knowing, okay? Anyways, when I hit enter, it's gonna say, well, take B2 and subtract from that B10, and you got yourself a mean deviation score, just like we saw, 22 minus 21.2, so positive 0.8. L. Sebastian's score on X is a little bit greater than the mean, 0.8 points greater than the mean. What about Kyle, all right? Well, Kyle is 18 minus 21.2. He's lower than the mean. He's like 3 points below the mean, okay? So again, I could type this in. It equals Kyle's score minus the mean, and I could put those strings there, and then I could hit enter, and yes, it is negative 3.2. That is Kyle's mean deviation score. Raw score is an 18, but when you subtract away the mean, it's negative 3.2, meaning 3.2 points below the mean. Hopefully that's good so far. Now you might think this is tedious to retype this, and you're right. You can just copy and paste, and then go ahead and check that equation, like this one right here. Okay, so it's B6, that's Ron's score on X minus the mean, that's in B10, and yes, 19 minus 21.2 is negative 2.2, all right? So why did that copy and paste work? Well, it knows, if we started here, it knows to take this score minus the mean, but remember we locked that mean box down with the dollar signs? Well, when I paste it, it knows to let the first box float, what was B3 become B4, but it kept the mean box locked where it is. So there we go. In fact, there's a faster way I could have done this pasting thing, and that is you can just grab right here and pull down, and bam, it does it. Okay, so little Excel guidance there about how to make equations and reproduce them. It's just important that you lock down whatever box needs to be locked down. If I'd let that mean box float and not have the string signs, then it would have just moved on down to here and we would have gotten bad values, all right? So as it stands though, we have computed mean deviation scores, and I think we can all agree, not difficult, was it? Easy to do by hand, but here, we're in the computer age, so we're not doing stuff by hand. All right, so I hope this is good so far. All right, now if you're not picking up on these Excel tips, it's not a big deal, all right? This isn't an Excel class. Excel's just a tool that we're gonna use. But I'm sharing these with you because they are, just worth knowing in general for life. So anyways, the first sort of pro tip was use that equal sign to have it compute stuff for you. And the second one is on using that dollar sign symbol or the string symbol to fix a box in place, all right? Or a cell in place. All right, so we got mean deviation scores, yippee. What now? Next up, we square them, okay? And once we have these squared mean deviation scores, then we can proceed to the last step, which is to add them up and divide by n. All right, you seeing that? What is variance? Variance is the mean of something. When you add stuff up and divide by n, you're computing a mean. It's the mean of something. It's not the mean of the raw scores. That's a mean. It's the mean of the squared mean deviation scores, which is how far is a score from the mean squared on average. That's what variance is telling you. The average distance between